Good morning, everyone. Super excited to be here. Beautiful city, beautiful conference. Thanks for having me. Before we start, a few words about at least what used to be me. Like 10 years ago, there used to be hobbies on the slide. I played tennis, cook, I played guitar, but frankly, JavaScript just smashed all of these hobbies. And I just keep it here as a monument for these old days. Fast forward today, I'm an Node.js consultant. I focus on Node.js and backend only. And I try to be good at it by doing mainly two things. First, I used to work with 10 projects every year, which allows me to see a lot of technologies and scenarios. Second, I summarize all the insights and best practices in my blog and my repo, Node.js best practices. It's a repository with more than 80 Node.js best practices. And there is also a lot of discussions there. And really proud of this project. It's one of the 10 most shared Node.js projects in GitHub. So I'll be glad if you pay a visit, even contribute maybe. Let's start. So this session is about my story as a developer who a few years ago kept failing with testing. And then I went into a trip of looking for new testing technique approaches, tools to overcome all these newer architectures and technologies. And I want to show you all the tools that I learned about and mostly how they change the way I'm thinking today about testing. So, what problem did I face? I was working with customer a few years ago and testing suddenly didn't work for us. Why? I tried to work by the book with the testing pyramid, which is a kind of a best practice for testing. Just curious, who here is familiar with the testing pyramid? Cool. For those of you who don't, it's a very simple model that dictates that most of your testing should be dedicated to unit testing, a type of testing that are focused on software objects, like a class, an object, and you usually test one function in isolation, means in memory, if there is call to some external API or database, you just don't do it, you fake it. And the lesser proportion of your test should go to more user-oriented flows, tests that check what the user really goes through in production, like including the DOM, the database, real APIs. And I don't know, it didn't work for me. And I was also asking myself, is it even possible that a model that was invented 15 years ago is still the only model that should be relevant for every application in the world, given all the dramatic changes that we have seen? Like when this model was invented, there was no cloud. We were using with VM, no microservices, no serverless. So I just started spending a lot of time of reading and learning about testing. I was trying to see what other people think. And I can tell you, Twitter is no short of dramas about TDD, no TDD, pyramid, no pyramid, a lot of provocative discussions. But if I summarize for you maybe hundreds of tweets, I can safely say that as of 2019, there is a growing consensus that we should rethink our testing strategy. Many of the testing industry leaders believe that we should try to adjust things for the modern architecture. Makes sense, right? So what specifically is not working? Few things. First, unit tests, they just don't test the real flow that your user is going through, right? The fact that I test some function in isolation doesn't mean that my entire real production flow will work. Not to mention that unit testing even don't aim to test things like database, DOM, important and critical layers of our application. So if you show this to a unit tester, he will wonder, so what's wrong here? Everything looks perfect, right? All the units. And Twitter is full of other examples where what happens when all unit tests pass, but you have no integration test? See, the dryer here is completely perfect. Also the garbage can, but together, not sure. Also the manufacturer of each of these doors, like thoroughly tested each one of them, but in production, you see we have some issue. This is actually my favorite one. Yeah, so we laughed on unit test, but so you might think, okay, so I will just focus on more on integration test and end-to-end test. I just must say integration test means different things to different people. I refer here to the wide integration test, those that test a lot of components together. And I think that they contradict our modern architecture. Why? You code something, might be some React component or a microservice, and usually your main principle is work on a small unit, work on a small microservices, keep it small, keep it isolated. But then, when you need to test it, you need to craft all of this, right? You need to test your microservices with 10 other microservices that don't even belong to you, and with all the AWS stack, SAS, SES, SQS, anything on a developer's computer, just feels like you're losing the whole purpose of the keep it small architecture, like microservice. And my main concern with the testing pyramid is that, is it really possible that one model can apply to all type of applications in the world? Think of it, we have so many type of applications. We have machine learning, IoT, data pipeline, e-commerce, rules-based application. To all of this type of application, one model? Some example from a project that I was part of recently. So I have a customer with sensors, many sensors in car. Sensors were sending a lot of data to our API, from there to Kafka, from there to a data warehouse, and then there are some UI that queries the data warehouse. And the customer asks me, which type of testing should we write here? And I'm kind of, usually unit test, but where do you write unit test here? Like, there's almost no logic. So it just doesn't work for other newer architecture types. Okay, so given those problems, I went to the next stage. I was looking for a solution. And I start reading, and mostly in Twitter, as you see. And at first I found this nice, newer, modern model, which is called the testing trophy. And it brings two new ideas to the table. First, we should also not think about testing, but also about the static analysis layer, like ESLinting and friend. And as you know, as of 2019, linting is not only about a static thing, it's also about critical rules that can find actual production bug, like you throw error the wrong way or similar. And also there are a lot of other static analysis tools, like complexity checker and many other tools that require no effort. You just configure it and you catch bugs free lunch. The other idea that this model brings to the table is that keep more on integration testing, because this is what your user is going through. So this is where you should focus. And I kind of like it, I find it useful, but still bothers me that we should apply one model to all type of applications in the world. So I keep on searching, and I find a lot of modern models. I won't cover this is just to show you that there is a great debate and traction around these testing ideas these days. Until I landed on this model. It comes from a great blog post, which I highly recommend for you to read, that is called testing microservices the same way. And it also brings two very refreshing ideas to your testing thinking. The first one is that you shouldn't think only about development time testing. You should think about reliability across the board. And I mean that you also have to plan in advance how you're going to monitor and ensure that this piece of code works correctly in production. Think about it in an holistic and holistic way, like how are you going to monitor it in production? How does your deployment look like? There are a lot of techniques that apply to the entire pipeline. Why focus only on this narrow stage? And the second great message that comes from this post is that there are a lot of testing technique and types. Why choose in advance only 3 of them and try to apply them over all applications in the world? Just look at this list and apply the right techniques for your specific problems. And I was looking at this and said, yes, this looks amazing to me. I want to try it. But the problem is that I'm not familiar with 80% of it. Like, what is config testing? What is fuzz testing? No idea. So naturally, the next step was, okay, I want to experiment these testing techniques. Let's try them. And this is what we're going to do now. Let's see some 5 lesser known testing technique. This was my toolbox when I started. I had 3. I'm just curious, who here is familiar with unit and integration testing? Great. Who here is familiar with more than 4 unit techniques? Okay. Very few, so great. It seems like a useful journey for all of us. Let's start. The first one in our portfolio is called property-based testing. And it aims to handle the challenge where our application often should handle infinite and unknown amount of inputs. Like always in production, we are surprised by the amount and variety of type of inputs we can get. Very hard to plan for this. And if we use this technique, it can greatly improve our unit and integration testing. Let me show you specifically what I mean. So we have this simple function. It receives a string, a number, and a Boolean. And this is typically how you would write a unit test, right? You sample. You choose some specific type of input. And then the output, unsurprisingly, on the console is this. So what's the problem with this? Usually you just choose 3, 5, maybe 10 samples. But this doesn't prove that your test covers all the edge cases and all the input permutation, right? This function upstairs, if it's a small function, calculate price offer, like multiple if-else, then yeah, it should be good to just sample. But a lot of time, behind this function, there might be other very complex layer that calculates the price. There might be other services involved with it. There might be a business rule, maybe even an AI model that helps in calculating the price. And it can be very hard to try to choose all the samples that cover what your function is going to go through. One more word about it. For me, from my experience, a lot of time in production, we try to predict all the value that might arrive, but there is always some values that suddenly turns to not fit some database field, or something that crash our regex. Who here heard about the Cloudflare shortage this month? Okay, Cloudflare is responsible for 10% of the internet traffic, and they were down this month. The reason for this, apparently, as they published this week, is some developer changed a regex on their platform, and there was some input. I'm sure he tested it. I don't know him in person, but I'm sure he tested for it. He probably tested few inputs. It looks okay. He put it in production. But then came some specific input that he didn't plan for, and he took the 10% of the internet down. So this is what property-based testing aims to improve. How it looks like. Same unit under test, same function. Then you use some specific library for property-based testing. There are multiple. And as you can see, the first line, you generate random value. You just tell him generate a string, generate an integer, generate a Boolean. And now it is going to invoke your function with 100, maybe thousands of different permutations. So the output, I'm sorry, I know that you can't see it on the back, but basically the output is now, this function is being called 1,000 times with all, not all, but many permutations. So if you just deploy to production and you have confidence based on 5 samples, consider how more confident you feel if you just tested it with thousands of permutations. Looks like a free lunch? Not exactly, because when we put it in a test case, you'll soon realize some fundamental challenge here. So this is the same code. I just try to put it in a test case, and I want to expect for something. But can you spot the problem here? What should I expect for if I don't know what is the input? The line above, this one, just generate dynamic input. So how can my test know what to expect for, right? And the answer, yeah, it's as you're going to see, it's a bit challenging. It's very useful, it's very powerful, but yeah, it's not easy. So what nevertheless can we do with property-based testing? Multiple things. First, we can detect failures, which if Cloudflare would try this to detect failures, it would have proven very helpful for them, right? So you can run your units, your API, your function with thousands of permutations and ensure that, for a start, the process never crash, or maybe even more specific, that your HTTP returns only the right statuses, that your code throw only valid errors, which is very useful in JavaScript. You can run your function with very rich input and ensure that or you get a value back or it is thrown a valid error object, which many times you see in JavaScript and Node.js application an error which is just a string or it is not tagged, not classified. By the way, this is what the Node.js core is doing, unfortunately. And of course, you can ensure that there are no DDoS. So this is one option. So, but you might think, okay, so it can't help us with functional testing, right? I can't test the correctness of my function, only that it doesn't crash. And no, there are techniques also to perform functional testing. It's a bit complicated, so I'll just show you one example. So let's imagine together a scenario. You work at the V8 JavaScript team, and you woke up some morning, and it turns out that you are on a shaming attack. Some troll on Twitter write this message. The string.includes message, part of JavaScript, right, is super slow. I hate it. I'm moving back to PHP. Unfortunately, this stupid message gets 4,000 retweets. Your boss calls you and asks, we might rewrite string includes and make it faster. You are the man. Okay? You find modern algorithms. You know how to implement it better. You just wrote includes version 2. It's much faster. Here it is, blazing fast implementation. You tested the performance. It's amazing. But how can you test that it is correct, that functionally it covers all the cases? Think of it, this function is going to be utilized in so many projects. It's JavaScript. Millions are going to feed this function with infinite type of inputs. How? You can't test it with 10 samples. How can you get the confidence? So there is a technique that is called the test oracle, which is quite simple, actually. This is our test case, very similar to the previous one as you see. So you can see what we basically do here. We generate value, the main string and the search string, and then we run it against our new method. Okay? So this value is what our new method just yielded back. But how can we assert that it is correct? What we can do is we can use the old version, the V1, the one that works only 10 years in production and was proven to work correctly. We can use this one to assert that our new function returns the right value. This one will serve as our oracle. And this way, you use your method with thousands of permutations, and you can prove, not sample, prove that it is correct. And by the way, you can also use property-based testing for your front-end code. Forms, for example, are a great candidate. Just fill your forms with many permutations. I also found this nice library, Gremlin.js. Basically, what it does, it just clicks everywhere on your screen many times. So it will simulate many occurrence of actions that you might have missed in your casual testing. Yeah, same here. Okay, so next time you really need to ensure that your function, next time you're in a situation where you know that you might get a lot of type of inputs from many type of system users, you have now a new toolbox, a new tool in your box, property-based testing. Next one in our portfolio is consumer-driven contracts. And it's meant to handle the scenario, which I'm sure most of you face, that you have an API or you're the consumer of the API, and there are great debates about you don't return the right fields, it's not the right value, you don't return the right error. There are a lot of discussion and debates between API creator and consumers about the schema and the return correctness. Consumer-driven contracts provide a very robust method to handle these contracts. Let's see an example. And you know what? By the way, before I start, maybe a short story that I just faced in production. We were creating some API for our consumer, which is a different customer. It was a very critical API, financial one, and the customer kept on complaining, "Hey, you are not returning the right field." And we kind of tell him, "Yeah, but we documented that we removed this field." And he said, "Yeah, but why is it in production now? I wasn't expected to be already in production." Then he was complaining about the errors we return. And we say, "Yeah, but this error is documented." And he kind of, "Yeah, but I didn't expect that for that input I will get that error." And this is the shortage of documentation. They are static. It doesn't tell where it's going to be in production, what would be the specific result for a specific input. And this is, as you're going to see soon, where consumer-driven contracts can help you. So how does it work? It's very interesting and disruptive. First, we use a framework called Pact. It has a flavor for every modern language, like JavaScript. And we have two parties, right? We have the consumer, might be a microservice, but it also might be your front end. And the provider, the one who codes the API. And now, surprisingly, the one who creates the tests, the expectation, is the consumer. So the consumer creates expectation files, which contains, for each route, what should be the result. Okay, so it comes from the consumer. Practically, it's more a collaborative practice where also the provider is engaged and they're doing it together, but it's the responsibility of the consumer, which then put it in a broker. A broker is some kind of medium in the middle between him and the provider, so both can read this file. Usually, it's a very specific service that it's part of the framework, a Docker image that receive these files and visualize them, as you're going to see soon. And then, on the next stage, the API creator, during testing, probably during CI, reads these expectations, then and replay them against its own API. He runs all the expectations against the API and ensures that there are no deviations. And if he finds something that the client expected otherwise, great, right? We found it during testing time. And in production, no changes. Just meant to show you that it's a development time mechanism. The aim is to catch it early. Let's see some code to make it more tangible. So these are the expectation files, the packed file look like. See, it's a very typical API description schema. If I send this, I expect for that. Very expressive API schema. Then the consumer during testing, every time he runs testing, Pact automatically will send these files to the broker. And then on the provider side, as you can see, he's using Pact. You just have to provide Pact basically with two values. One, where is the broker? This is where you read the expectation file. And the second parameter, this is where the API is. This is all what Pact needs. Give me the expectation, give me the API, and I will compare the reality versus the expectation. And once this verification runs, it saves the result to the broker. This is how the broker UI might look like. And the nice thing is that if you have 20 integrations, like you can get up to date, up to the minute snapshot of what is the current status. You can see for every consumer, every provider. And if you see something like this, you should worry. This shows you when for the last time the provider ran the expectation of the consumer. And it looks like for some consumer, they didn't run quite a long time, and we're about to deploy to production tomorrow. We are not on the same page. It gives you a red flag early that this integration is risky. So next time you have a critical integration, something that must succeed, must be, the parties must be very much aligned. You have now something that obviously unit and integration test can help you with. End-to-end test maybe, but it's very expensive only for this purpose. You have a new tool in your box. Next one is mutation-based testing. And it aims to handle the fact that coverage sometimes is a liar. And what do I mean? I think that I better show this with a demo. By the way, this is not a testing type. It's a technique to measure test effectiveness, like coverage. I just wanted to show you because to show that there are newer techniques not only for test type, but for almost everything in the testing ecosystem. Okay, so code is font is big enough. Great. So I have some very simple function here, as you see, and I want to be sure that it is tested correctly. How do I do it? Imagine obviously that it is much longer. How can I ensure that I have tested this code thoroughly? So I think the obvious technique is to just intentionally create here bug. I will start change lines here. Really? Whoa. I will just change lines here. And if my tests keep on succeeding, that they are not testing it right, correct? Like for example, if I will just go to my code and I will change this to 7 and change this operator to not and this to divide, you would expect the testing to fail, right? Otherwise, what are they doing? And in fact, I wrote some testing, and I have nice coverage. For those of you from the back who can't see, it's 80% coverage. And the tests keep running, but no matter what I do to my code, the tests keep succeeding. 80% coverage, and I just screw the code, and the test just passed. So what's going on here? And the reason now let's see the test, and you realize the reason rather quick. So these are the tests. And as you can see, they just invoke the function, but they don't test anything. And this teaches us that coverage is a measurement that tells us where the test goes to arrive to, but not whether it tests anything. Obviously, what is missing in the test is this part. There was? How much?
0 expects.
Whoa, amazing. By the way, there are linting for that. I highly suggest it. What the name?
The name of the project?
Your name. Pavel. So what Pavel says that he had the project where with 90% coverage, and when they manually checked the test, there was not even one assertion, one expect. My advice, there is a linter that catches that each test has at least one assertion. So property-based testing, mutation testing handles this very, very, very interestingly. What it does is what I did manually. It goes to your code, really, it goes to your code, and it changes each line. It like screw the line, it changes the operator. If it's equal, not equal. If it's divide, multiply. Then you run your test. If your test pass, something is wrong, right? How can it change lines and your test keep on passing? Then it counts you one bad point. If the test failed, then it's great. They catch that, and so it actually measure exactly if your tests are testing for each one line of code. Let me show you a quick demo. Okay, I'm using a tool called Striker. It's a mutation testing framework for JavaScript. Great one, by the way. I just click Striker Run. This is also a nice part. I don't have to code anything. Just configure the tool, run it. Now it runs. What Striker does, it goes over each one of your line of code, change it, run the testing. Change it, run the testing, and counts how many times your test didn't catch a line change. And it creates a report. Let's see it in a HTML. Let me find it. Reports, mutation, index. Okay, so basically it tells you how many killed, how many survived. Killed, it's a good thing. Means you change line, the test failed. Your test killed the mutation, great. Survived means that your test didn't realize the code change, and this is of course bad. So your goal is to have as much mutation killed as possible. You can count it in your CI. And when you drill down to the code level, it shows you exactly which of your lines is not tested. See, if I go to this, Striker changed it from is on sale to false. And my test didn't catch that. So I know this line is not tested. It's kind of specific instruction where which areas or which lines are not covered well enough. And the main point here is that unlike coverage, mutation actually tests that your tests are asserting, expecting that your code will do things, and not just arriving to the right lines. Okay. Due to time limit, I will skip the next one, component test. I have only 10 minutes, and I want to show other things. Just in a brief, maybe. What is this one? Okay. Okay, so maybe just 30 seconds about it. Component testing is a kind of hybrid between unit and integration testing. You basically, if you work with a microservice environment, your test the entire microservice. So it's very realistic. It goes through all the layers, the API, the data access layer. So it gives you a high confidence because it is exactly what your user is going to go through. But anything that is outside, like a different microservice, a call to other services, or the database, are faked. So, for example, if you call other microservice, you just use libraries like Noke to fake it. If you call a database, you can use an in-memory database. So this way, you get the reliability of integration test, but with the speed of unit testing almost, because there is no I/O, right? If you fake the network calls and the database is in memory, then no I/O. It is almost, I measured it, almost as fast as unit test. So you enjoy the good from both worlds, okay? Both reliable and both relatively quick. Usually see code example, we will skip it due to the time limit. And go to our final one, chaos testing. And chaos testing is here to remind us that no matter how good is your code and how great are your functional testing, there are always things unknown, weird from behind, from the side that affect your application. Might be the infrastructure, might be NPM packages that behaves abnormally in your code. I think that this tweet summarized the idea of chaos testing great. So a QA engineer walks into a bar. He orders a beer, orders 0 beer, orders 999.99 beer, orders a lizard, orders -1, orders something. Guess what? All test pass. Looks perfect. Let's take this bar to production. Yeah? First real customer walks in and asks, where the bathroom is? The bar bursts into flame, killing everyone. Only when you put your code in production, you realize what your customers are really asking. And the idea of chaos testing is to encourage you to simulate this chaos in advance, or maybe in production also, but proactively, realize it, and handle it. We're going to see soon how can we handle it. Let me exemplify it with a very traditional tool, and soon I'm going to demonstrate a JavaScript library that I wrote that is doing JavaScript-related chaos testing. So, this is something that is called the Netflix Chaos Monkey. It's a traditional chaos tool, and this is its Kubernetes flavor. Basically, if you just put this YAML in production in Kubernetes, you just won a Trojan horse, a monkey, killing containers where the bravest of us put it in production. Frankly, most of my customers doing it in staging. And the benefit is that you can, containers will die in production. So the question is whether you're going to test it in advance or not. This gives you the opportunity to see what happens when your containers die. And then you would expect two positive things. One, self-healing, okay? Some things that will recover for this shortage. And second, that your monitoring system realize this chaos. So we can generalize this rule and say that chaos testing is about first simulation tools, like servers that kill monkey, some tools that create network outages, maybe also some code, process level chaos, let's see soon. And then reaction. Your reaction is handle it, do the best that you can given the chaos. And second, monitoring, very critical. A lot of time you can't predict, you can't test, you can't prevent. But if you can set the right metrics and the right monitoring system and catch things fast enough, this might be the best things that you can, and you will provide a quick remedy. Then I thought to myself, that this type of tools will get less and less efficient with time, right? Because the infrastructure becomes really reliable. Like if you kill a Kubernetes container, believe me, I did it 1,000 times, it will come back to life again. Networks, because highly monitoring about our cloud providers, and there are a lot of tools to heal it. But what about our code, our JavaScript process? Do we measure, do we test what happens when we have chaos? What is a JavaScript chaos? Something, maybe our code, maybe third-party library, block the event loop. Maybe the V8 memory is out of range. There is some uncaught errors on uncaught promise. Things that happens within our code. From what I see, most of the teams that I meet don't test for these things. I don't know, it's just not a known practice. There are no tools for this. So for this reason, I wrote a small project. It is still alpha. I didn't really release it. Let me show you now a demo. It's called Node Chaos Monkey. I need 3 minutes. Okay. This is the naughty and cute monkey. And basically what it does is that you can inject it into your project, and it will start creating chaos within your JavaScript. To install it, you have to do nothing more than same way you always start your Node.js code, just inject -r flag the chaos monkey. And then, let me show you live. Okay, so basically what I did here, I have a very typical Express API, and I'm about to load it tomorrow to production. Unit test pass, functionality, I feel confident, but I want to ensure that it survives all the type of chaos that I just show you. So how can I do it? I just injected the chaos monkey into my API. And then I get a UI, this UI, where I can do basically 2 things. On the left side, I choose what type of chaos I want to simulate. What is a chaos? Make my API returns 500 errors. You want your monitoring to discover this, right? Uncaught exceptions by a third-party library, unhandled promise rejection, overload the memory, overload the CPU, block the event loop, break integration with other services like Stack blocking the network. Or I can choose a pre-plan with just surprise me, just do a lot, just shoot out a lot of type of chaos. And then when I click start, the chaos monkey on the right side will keep calling my API and measure to which extent it was affected by the chaos. Is it still alive? What is the error rate? And I can get some visualization whether my code survives the chaos. To benefit this, I have to define what is my API URL. We have plans in the future to allow you to import Swagger or Graph. So if someone wants to join and contribute, I'll be honored. Okay, so let's choose some chaos and run it. Okay, the chaos monkey started. As you can see here, it is emitting a lot of chaos type. It is now messing with your production, but my API survives everything. I'm about to go live tomorrow on production, and it's it. Oh no. Suddenly, it seems that like something rendered my application down. What is it? Okay, at least I realize it soon enough. Basically what I do right now, first I'm going to my monitoring system. I want to ensure that there is some kind of alert. This is the most critical thing. If my monitoring system didn't realize that my process went down, I mean, this is real chaos. Second thing, I go to the logs, I try to understand what happened. I don't have time, sorry, so I'll just save this part. When I go to my log, I realize that some third-party NPM library throw an unhandled promise rejection. And I'm not sure if you know, but in Node.js, if you don't proactively do something about it, it will render your process down. So this tool allowed me to learn it, realize it, and fix it soon enough. So we have seen 5, at least 4.5 new test types, which I hope you find useful. But I think that my main takeaway, my personal, maybe yours, is not about only just learning more and more test types. Rather, it's about how we test how we plan our next testing projects. And this is my takeaway. You might work with a model. You might start with some pre-planned model. And if you do so, if you want to stick for start to a model, then I would say that there is a movement from a pyramid to a diamond. You would see many experts doing this, moving from focus on unit testing to more integration testing. Mostly those narrow integration testing which are fast. So look at this trend. It's an important trend that you should be familiar with. This is maybe the modern model. But at many times a model won't be enough for you. You've seen so many types of application and problems that this type of testing won't cover for you. So sometimes go outside of the model and try to cherry pick the right testing techniques for your specific problem. If you have contract problem with your customer, unit test won't help you, neither integration test. There is contract testing. So if you enrich your testing portfolio, you would be able to match the right test type for each of the problems that you will face in your applications. Thank you. It was a pleasure.